Hello guys, I'm Sandip. I'm back. Right. So if you do remember, we started with the chapter force, or we can say laws of motion actually. Newton's laws of motion, right? So I told you already. When we say laws of motion, it is actually the Newton's laws of motion, right? Because Newton is a scientist who did research on that laws of motion, mechanics, forces, and all that stuff, right? Then we already have completed the 2 sessions on this. So if you haven't seen those sessions, right, I'll recommend you to go and watch those sessions first, and you can check out this third session. Okay. So what we studied, if anybody able to recall. So in laws of motion, we actually started with a small definition of the force, that any push or pull. If you do remember, I gave you the example of your car, right? You and your brother was pushing the car when the car was broke down, and you want to take the car to the garage. You and your brother pushes the car. That is the force. Or the tow truck is pulling the car. That is your force again, right? Okay. So that part we already completed. Laws of motion are there, right? First one deals with what? Inertia. So hopefully now you know that what is inertia. So first law says that every object which which is in state of rest or state of motion, we can say, will remain as it is unless acted upon by unbalanced force. Okay. Then what is second law? Second law, I gave you the example of the cricket match, that if the Dhoni or Chris Gill wants to hit the six, what they are going to do? They are going to apply force, or we can say momentum, to the ball, and the change in that momentum is directly proportional to force. That is the second law. Or we can say force is directly proportional to what? Rate of change of momentum. Simple. Or we can say also say in the second statement of that law is force is equal to mass into acceleration. So obviously if the mass is big, then you need a lot of force. For example, you can consider if you want to move the big cupboard in your home, obviously you cannot move that alone, right? You'll need someone. That. Okay. We have seen that. And third law is very simple, right? Every action has equal and opposite reaction. I know that everybody now memorizes that third law, so nobody could forget the third law. Right? Very easy to understand or memorize. Okay. Then we also studied the two very important forces: normal force and tension force. Right. So two forces we studied there, and those are actually electrostatic force, how they apply. And I told you the one important concept about the normal. Normal always acts perpendicular to the surface. Very easy. Okay. Then also we talked about the tension, and tension I said that what is to remember that tension is the pulling force. Okay. And in case of normal, I actually told you to solve one of the questions. So hopefully you have tried it. So let's see and check your answers also. So this is M2G force acting on here, M2G force is acting on here, and M1G is acting here. Right? So gravitational force or weight, we can say, is always acts downward. That we know. So I mark the forces for everybody. What they want us to calculate: normal reactions at all interfaces. 4 interfaces. Where are the 4 interfaces? We can say first interface is this one, second one is this one, third one is here, and fourth one is here. Right? So remember, this M2 are same, and can I say that M1 is equally lying on that M1 and M2? Therefore, I can actually say this is, let's call this as N1, or let's say N2, and this is also N2. N2 and N2, they are same forces. Why? Because both the masses block is same. Similarly, I can also say N1 and N1 here. Right. So N1 is the force applied by what? Both the M2 masses on the bigger that M1 block. That is our N1. Similarly, by action reaction, we already know that M1, that bigger block, will also apply some force here. How much? Same force, N1, N1. So that N1 is acting on whom now? This M2 block, right? So this M2 block. So once we marked out all the forces, now let's try to draw the MBD. So first of all, the MBD of the, let's say, these two small blocks. So M2G is there. Then this N2 I can see, and N1 is acting downward like this. Can I say this second block will also have the same forces, N2 and N1. Let's talk about the bigger block. For that bigger block, one force is acting as M1G. Here I can see one force is there which is acting upward. Let's show it here now, N1, and here is also N1. Okay, now what is our job? Just to equate all the vertical forces, upward versus downward. So upward is equal to downward. So upward, two N1 forces are there, and this is M1G. Very simple. So what I can say, N1 is equal to what? M1G by 2. Right? Now let's try this one. Now both the blocks have the same forces acting on them. So we don't have to write the separate equations for those. We will just solve for one block only, right? So let's talk about this block. What we know, upward forces is equal to downward. Which one is upward? Only N2 is upward, right? N1 is downward. You can see the arrow is downward, right? So N2 is equal to what I can say? N1 is downward, plus M2G is also downward, right? And how much is the N1? Here we have no. So M1G by 2 plus M2G. Right? So this is a small formula you can say, or if you modify this, you'll get something like this. This is your N2. So what they have asked us, 4 normal reactions at the 4 interfaces. 4 interfaces means already we know that these are N1, N1, N2, N2. So anyway, N1, N1 are same. So we got the N1. So N1 will act at these 2 interfaces, and N2 will act at the 2. Right? So that's it. So very simple process. You just mark all the forces, and equate vertically upward to the vertically downward forces. Okay. So this is a question. Hopefully you would have done this question as a homework. I have told you to do that in the homework in the previous session. So check your answers whether they are right. Okay. Good. Now let's see what we are going to study in this chapter. The friction. What is friction? Right. So consider one example that in the rainy season. What happens in the rainy season on the road? Right. Tell me, will you drive the bike or ride the bike faster in rainy season or our normal summer or winter season? Obviously, in rainy season, your bike will be slower. Why you are doing that? Because in rainy season, what happens? That road becomes wet. Right? If it becomes wet, there is maximum possibility that the bike will slip. So what we do? We ride it slowly. Right? Why that is happening? Why the road becomes wet? So we have to drive it slowly. What happens when that road becomes wet? Right? So the answer is friction. Right? So we also have to discuss a little bit about the friction. That yes, friction is opposing the motion that we know. Friction is also causing the wear and tear of your tires of the bike. Means what? What is the meaning of that? Right? You actually change the tires of your bike or cars after some years, right? Why? Because of that friction, and your car is driving on the road. That friction actually ruins your tire. We can say it makes it smoother, right? So yes, we can say friction is not a good thing. It is opposing. It is harmful. Even you can consider the sole of the shoes, right? Or sleepers, we can say. We also have to change the sleepers or shoes after 2 years, right? 2-3 years, right? Some people change it 1 year or 1 month also. Right? So why? Because of that friction. Friction is causing that sole, we can say, sole will become smooth. Initially, when you bought the new slippers or sandals or shoes, we can say, you can check the sole. Sole is rough. It's not smooth, right? Friction makes it smooth. And why it is not good? Obviously, if the slipper is smooth, then we will sleep, right? We will fall on the ground. Right? So, so now tell me, the friction is not there. Consider friction. We remove the friction from the whole world. What will happen? Everything will become smooth. Is it good now? Obviously not, right? We will fall down. We cannot even start walking if there is no friction, right? So friction is a very important thing. Now here also you can see that small animal is climbing on the tree. Why? Because there is friction between its hand or legs, we can say, and that tree. Then only it is possible. Even you can assume if you want to climb on the tree, that if the tree is very, very smooth, then it becomes very hard to climb on that. Right? If it is rough, then you can easily climb it. Because there is a friction, and friction, though friction is, we can say, not good, it is opposing the motion, we can say, or it is wearing, there is a wear and tear of the tires or sleepers, but still we require the friction. We cannot do anything without the friction. We cannot walk, we cannot ride, right? Like this, we cannot climb the trees. Right? So friction is, so therefore they actually say that friction is a necessary evil. Remember, they say that friction is a necessary evil. Evil means what? Bad thing, right? It is harmful, we can say. So, but it is also necessary. So, friction is a necessary evil. Remember that part. Then we are going to study about the limiting static friction and coefficient of kinetic friction. So, actually, there are three types of friction, we can say. One is the static force of friction, then kinetic force of friction, and there is one more, that is rolling force of friction. Now let me ask you one question. If you want to move your, let's say, cupboard, or let's say washing machine, right? Washing machine, and anyway, you can move the washing machine, but if you want to move the cupboard, what will you do? You cannot move that bigger cupboard, right? So you will call your friends or brother or sister to help you to move that cupboard, right? Why? Because it is applying, it is giving you some friction, right? It is opposing the motion. What is the job of the friction? To oppose the motion, right? So it is really difficult to move the friction, move the cupboard. But now consider, if you apply the small wheels to the legs of the cupboard, you can say, just like a washing machine. Nowadays, washing machine come with that small legs, right? Now consider your cupboard also has the small legs, right? What will happen? Small leg means small wheels, we can say, right? Like a skating wheels, we can say. So now, do you need the help of your friends or brother or sister? No. If it has wheels, it will easily move, right? Why it is happening like that? Is there a friction? It's completely gone. No, there is a friction, but there is a rolling friction now. Why? Because that ball is rolling, right? And it is carrying the whole load of the cupboard. So now the friction is less, so you can easily move it. So what I can say, rolling friction. Can I say rolling friction is less than static friction? Easy to understand, right? This is your daily example, you can say. It is very difficult to move the big cupboard, but if it does have the rolls or the wheels, we can say smaller wheels, then it is very easy. Okay. So this is the example. You can say, then what about the kinetic friction? We now know what is rolling friction, what is static friction. Now, what is kinetic friction? We are going to see this in this upcoming slides. Okay. So now let's start. So first is, let's see what is friction. So force resisting the relative motion of one body over the other is called as friction. Very easy to understand. So if you apply the force on the cupboard, that is not going to move because frictional force is also acting from the opposite side. Right? So always remember frictional force is always opposite to the applied force. So if consider this is your cupboard, you are pushing this from this side, friction force will go here. Now you will think, you will say, let's go and try from this side. So now suppose you are pushing from this side, friction is very clever. It goes from the other side, right? So friction changes its own direction, right? Very easy to understand. Right? So Now, these are some examples of the friction you can say. Here, towel is hanging on the bathroom rod, we can say this rack, right? So if it is hanging on the rack, assume that it is smooth, there is no friction. Now, smooth material is there, then what will happen? The towel will not remain there. It will slide on that, sleep on that. Very simple. Then car parked on a hill. So if the car is something like this, and if you don't apply that handbrake, then that car is not going to stay like this, right? Because it is inclined here, you can see, right? So normally on the normal road, what happens? If you keep the car like this here, right? Okay. So this is the car. Then obviously it will not go anywhere normally, right? Why it is not moving? Because there is a friction. Here also you can say, even though there is an inclined plane, some friction is there, right? But it is difficult when it becomes inclined. There are other forces are also there, and it is going to take that car downward. So you have to apply the handbrake there in this case. Very important thing, right? Okay. So force of resistance of an object on an object that causes body to stop moving. Just causes body to moving, you can say not stop. Force of resistance on an object that causes body to start moving, you can say, right? Instead of stop moving, let's say start moving, right? Very simple. Examples you can see here. Also, you can take your example of the cupboard, right? Cupboard you are pushing, but it is not getting pushed because whatever force you are applying, that frictional force is also getting applied there, right? And also we know that friction force is very clever. It gets applied on the other side. That is also the big problem for us to move that cupboard. Right? So that is the static force of friction. So whenever the object is at rest, cupboard is at rest, this car is at rest, towel is at rest. So when we say the object is at rest, the friction acting on that is called as static force of friction. Okay. Remember. Now let's see about the magnitude. Now I told you that friction is very clever, right? That it gets applied, it changes the direction itself. Wherever you are applying, it will go in the opposite direction. But it's not that. It is more clever than that. You can say friction force is more clever than that. How? It not only changes the direction, it also changes its magnitude too. How? Consider if this is the block, you can see. First of all, the push was 1 Newton, right? Friction force also you can observe, and it is also 1 Newton. If you apply 2.5, friction becomes 2.5, right? So friction is also what doing? It is not only changing the direction, it also changes its own magnitude too, right? We can take our cupboards example. What is happening in cupboards case? Let me draw it here. So this is your cupboard. If you push this cupboard, let's say from the side, cupboard become very big now. Okay. Anyway, so you're applying some force, and we already know friction force also starts applying from the opposite side. Now consider if you call your brother to help. So he's also applying some force. So how much you force? Suppose you applied the force of, let's say, 10 Newton. Brother also applied, but friction force got 10 Newton. When the brother also apply force, let's say, he applies the force 20 Newton. So how much total force you are applying? Let's say 30 Newton. So friction also becomes 30. So that is why we are going to call it as self-adjusting force, right? Okay, because it is not only adjusting the direction, it is also adjusting its magnitude. So can I say it adjusts magnitude and it also adjusts direction. So in exam, you could get one question like this, that why the friction is called as self-adjusting force. You have to prove that it is also, you have to show that, not prove, but you have to show using some examples like that block example you can take, that it also adjusts the magnitude and also adjusts the direction. Okay, so this is the static force of friction. Now, obviously, we know that if two of you are trying to move that object cupboard, we can say it is not moving. Suppose you bring your sister also to help you, right? Now, can we say that your sister also helping you? After some force you are applying, obviously it's not like that friction is going to adjust its value always. Up to some limit, it has some limit, right? Some after some time, when you apply the enough force, you 2 3 are applying the force together, then cupboard will obviously going to move. And friction apply the infinite value? No, right? So that friction also has a limit. Even in this block also you can see after 2.5 it stops. Right? It does not increase because it has some value. It has some limit up to which it will act. That value is called as, remember, limiting static force of friction. Right? Limiting static force of friction. So after, if you apply the force equal to that, then cupboard will start moving. So what they are saying, the highest value of static friction which comes into play when the object is just about to slide over the surface of different object, right? So what actually you can say that that is the highest value of the friction. Here in the blocks case, small block, you can see what is the highest value. 1 is there, 2 is there, 2.5 is there, but it is not going after that. If you apply the 2.6 force, then that block is going to move. Same thing is going to happen with your cupboard too, right? After some particular value, it is going to move cupboard. You can move the cupboard obviously. So that value is the limiting static force of friction. But how much it is, right? So can I say it is very easy to move the small block, you can say. Suppose you have the laptop in front of you. It is very easy to move that laptop. It's not that difficult. But cupboard is taking a lot of force, we can say. Can I say that the friction acting on your laptop is less than friction acting on that cupboard? Or rather, let's say highest value. Highest means what? This limiting. So limiting static friction acting on your laptop is lot more than, very less than limiting static friction acting on your cupboard. Okay. So think on that and tell me what should be the factor who is increasing that value? Can I say mass? Perfect, right? Obviously, it is very easy to understand. Heavy object will take more force to move, right? So it's limiting static force of friction. We can say this limiting static force of friction depends on the mass. More accurately, now instead of saying mass, more accurately, we can say it is dependent on the normal reaction. Obviously, normal reaction also has the component of mass. So yes, it will take care of it, right? So why I'm saying that? So consider if you obviously want to move the cupboard. So suppose this is the horizontal surface, but now consider this is the cupboard, and you want to move this on this inclined plane. What will happen? It will be easier, right? Because it is an inclined plane. You want to move downward. If you want to move upward, then it will be more difficult than our normal horizontal cases. So, is mass changing there? No. Mass and weight are not changing. Who is changing? I told you. Very important to notice that normal force is the one who is changing with the incline. So yes, it is dependent. Force of friction depends on mass, yes, but we have seen for the different cases, if the plane is inclined, then it becomes easier to move that object, move that cupboard downward, or it is difficult to move that cupboard upward, right? So instead of saying on mass, let's say it is dependent on normal, right? And remember that normal ultimately depends on the mass again. So we can say this, yes, force of friction also depends on the mass. Okay. So now the formula or the magnitude we can say of the limiting friction. Limiting means what? Highest friction offered by the object is our limiting friction, right? So we know that part, and we need one formula for that. Obviously, how much friction your laptop is giving, or how much friction your cupboard is applying. For that, F max is given as formula is mu s into n. N we already know. N is our normal force. What is mu s? Now this mu s is a new term. Mu s is called as coefficient of static friction. Remember this part. Mu s is called as coefficient of static friction. Why static? Because object is at rest right now, right? So therefore we are going to call it as coefficient of static friction. So it depends on what? What is the value of coefficient of static friction? It is changing value. It's not constant, right? Constant means obviously it is constant for two materials. For which materials, which object the object you are moving on, and which surface. Like cupboard is moving on the ground, laptop or floor we can say, not ground. Floor is laptop is moving on your table. Then you can say your bike is moving on the road, that is tire and road. So those are the materials on which that coefficient of static friction depends on. Okay. And if you know the value of that coefficient of static friction, we can easily calculate the force of friction, whatever force of friction is acting there. Okay. So now consider this is a cupboard. And let's say the mass of this cupboard is how much kg you can take. Let's say 50 kg. 50 kg is the mass of your cupboard. Okay. And we want to calculate. Suppose I will also provide you the mu s. Mu s means what? Mu s is the we can say coefficient of static friction between this cupboard and the ground. Let's say it is 0.4. Okay. So now can you calculate how much frictional force FL? FL means what? There are two things. FS is what? Static friction, right? Static force of friction. FL is limiting force of friction. And limiting is nothing but the type of static. Or we can say it is the highest magnitude of static friction. So FS and FL. And then we have the FK also, kinetic friction. We are going to see that anyway. Then we also have the rolling friction, right? We have seen that. Rolling friction. So these are the different symbols of the friction, you can say. So friction FL means limiting, means maximum force of friction. We do not have this formula for this EFS, right? Normally we interchange, we can even say limiting force of friction is FS. But for just right now, consider FL is your limiting force of friction, right? And the formula we already know, mu into N, right? This is our formula. What is the value of N? We don't know that. So let's see. So when we say mass, it is dependent on mass, right? So can I say mass is something like that? Okay, I haven't kept the place for you to push that cupboard, right? Let me do one thing. Let's draw this cupboard on this side. Okay. This, let me draw a nice handle. like this. Okay. Now, what we know about this normal force, we want the normal force in the formula, right? Before that, let's mark the mg. Mg is acting downward, we know that. And where is the normal? If this is the ground, normal is upward. It is shown here, right? And it is perpendicular to the surface. We know that point very clearly now. That normal always acts perpendicular to the surface. Is any other force? You are not pushing that cupboard right now. So can I say only two forces are there? So let's equate two forces. N is equal to mg. So simply can I say this becomes mu into mg? Simple. Okay. So we got m is equal to 50. You already know the g's. The value is 10 meter. Approximate value of g, we can take it as 10 meter per second square. We know that part. Okay, so let's substitute it here. So 0.4 into mass is 50 kg and this is 10. So how much is this calculation? Once you do this calculation, you'll get 200 Newton. So this is the maximum value force can apply. So what is the meaning of that? Right. So let's do one thing. I'll prepare one table here for the applied force. Okay. Need some. So let's write it here only. Applied force and frictional force. Now this 200 Newton is the maximum value we got, right? But now already we know that you started pushing it, right? With some force. Consider you're applying some force, let's say 50 Newton on this. Frictional force, now your direction of the force is this one, right? So frictional force is where? Can I say it is from this one? Yes. How much is the frictional force? I told you already that if you apply the 50 Newton force, frictional force also becomes 50 Newton. If you push it little harder, let's say 80 Newton, this also becomes 80 Newton. After that, you call your brother, and what happened? He also pushes, let's say he pushes with 100 Newton, right? So if he applies the force, let's say not 100, let's say 70 Newton. If he directly applies the force 70 Newton. So total force is how much? You are applying 80, he applied the 70. So 150 Newton. What is the frictional force? We know frictional force is what? Self-adjusting. So it also becomes higher. Right? Then what you did? You called your brother or your sister also, right? To help you. Right. Now let's say she applies the 50 Newton force. So what is your total force now? 50 plus you are applying 80, brother is applying 70, your sister is applying 50, total become 200 Newton. Now you can see that that is the maximum value of frictional force. So at this point, remember that cupboard will just start moving. Cupboard will just start moving, we can say. So frictional force also becomes 200 Newton. Right? Now consider if you apply a little bit more force, consider 210 Newton force. What should be the frictional force? Right? Friction cannot go beyond 200, right? So will it be 200 Newton? Right? No. Right? Why no? That will give we will understand in the kinetic friction, right? So first of all, let's do one thing. Let's try to plot this two frictional force versus applied force. So let's plot one graph. So this is your applied force. And let's say this is your frictional force. Right? So when you apply the 50, let me mark this as 50, 100, 150, 200. Let's say this is 250. Friction force is also 50, 100, 150, 200, 250. Okay, so for 50, frictional force was also 50. So what you can do here, this is 50. For 100, it becomes 100. 150, 150, that's right. 8, okay, we haven't applied the 100. No, 80, 80 you can. So 80 will be somewhere here. So this will be the point, right? For 200 also it is 200. So yes, it is representing the very straight line. So it is directly proportional, you can say. So this is your graph. Okay. So as I said that yes, if you now increase up to 200 or let's say 250 for this point, can it be 200? No. Will it be greater? Obviously not. Friction cannot apply the greater force than that. Okay. So what will happen? So for that we need the new concept, which is kinetic friction. Right? So static friction we already talked. When the cupboard was at rest or any object is at rest, then the static friction is acting. Now let's see what is kinetic friction. The force of resistance on an object that prevents the motion. So what is the difference? Let's see what is static friction. They said what is static friction? The force of resistance of an object that causes the body to, okay, this is not written correctly. The force of resistance of an object, not stop moving, you can say. Let's change a little bit this difference. The force of resistance on an object that that force which will not let object or body to start motion. If I have written this initially, just change this a little bit there. So this is the correct definition or correct meaning, we can say. Force of resistance on an object is that force means that force, or right area, is that force which will not let body to start motion, because that static force of friction is not letting the cupboard to move, right? Like that. Okay. What is kinetic friction? The force of resistance on an object that prevents the motion. So what is the meaning of that? Kinetic means you must have already seen the kinetic energy. It is similar to that. So when we say static, in static, remember, body is at rest. When we say kinetic, body is already in motion. Does that mean that friction stops acting? No. Even the body is in motion, friction is there, obviously, right? Okay, but obviously it is represented by Fk and its value changes, friction's value changes. How it changes, that we are going to see. So let's say the examples was the force of resistance on an object that prevents the motion. You can say examples. Rubbing both hands together to create it. When you are rubbing the two hands, there is a friction, obviously. This person sliding down the slide, obviously there is a friction. Right? So what is the formula here? Formula, you can see the formula is almost similar. Fk you are saying, right? So for Fl, we have written one formula, that is mu s into n. Fk, you can see formula becomes mu k into n. Now, what is Fk? Fk is kinetic friction. We have already written that in the earlier slide. En is same thing. Mu k is changing here. What is mu k? Coefficient of kinetic friction. What is mu? What was mu s? I have written that as coefficient of static friction. This is what is changing. Right now, tell me one thing. When you are applying force on the cupboard, right? It is very difficult to start the motion of the cupboard. But when it started sliding, is it difficult or it becomes easier now when it started sliding, started moving? Yes, it becomes easier once it started. Why? Because it is in motion. And when it is in motion, we call it as a kinetic motion. And the friction that time is acting as a kinetic friction. As you already have imagined, visualize that when the cupboard is started moving, then it is easier. Why? Because the kinetic friction becomes less than the static friction. So remember, kinetic friction, we already know that rolling friction is less. So kinetic friction is lesser than static friction. and rolling friction is even less than kinetic friction. So this is the correct, you can say, analogy here. Rolling friction is the smallest, then kinetic friction, then static friction. So it is very difficult for cupboard to start moving. But when it starts sliding or moving, it is a little bit easier. That is the kinetic friction comes into play. If you apply the wheels there, then there is a rolling friction. It is very easy. So how it becomes easier? It is because of this mu k, right? So mu k, we can say this mu k is less than mu s, and again mu r, you can say, is less than mu k. This coefficient of kinetic friction changes everything, right? So already, whatever is the mu s, mu k will be less than that. So now let's come back to our this cupboards situation. So consider mu s is 0.4. Let's take mu k as 0.3. Why? Because we know mu k is less, right? What I can say, fk becomes how much? Mu n. This is the formula, mu k n. This is mu s n, right? Or we can say mu k mg, or 0.3, mass is 50, g is 10. Can I say this is 150 Newton? Yes. So when the cupboard starts moving, once the cupboard starts moving, frictional force is not the 200 Newton. It cannot apply even the maximum force. Its value changes to frictional force of kinetic friction, we can say, which is in this case is 150. So when you apply 210 Newton, which is exceeding your limiting force of friction, then the value of friction becomes 150 Newton. Doesn't matter if you increase the force even more, friction is going to remain 150. Consider you just apply 201 Newton, so just a little bit, then also this becomes 150 Newton. Just a little bit you are changing, right? So I can show for 200 only, almost 200, the force becomes 150. This is also 150. For 210 also it is 150. Again 150, right? So graph will look something like this. Okay, so this is the frictional force versus applied force, and kinetic friction, static friction. Very easy to understand. Kinetic friction is less than. Formula is similar, only that mu k is changing. Mu k is what? Coefficient of kinetic friction. Okay, so you can see one graph, same graph we actually have drawn when we are trying to push the cupboard, right? You can see the same graph there. Okay. So this is the whole theory part of our today's session. That is force of friction, right? So let's see one question on that. A man tries to remain in a steady state by pushing his feet and hands against two parallel walls. I don't know why he's doing it. He's doing something like that. Two parallel walls are there, and he's trying to become horizontal like that. Then the for equilibrium, let's take the first. He must exert the equal forces on the two walls. If the walls are similar, remember, if the walls are similar, then yes, he must apply this equal forces. But they haven't mentioned anything like that, right? So this is not true. The forces of the friction at the two walls must be equal. Again, if the walls are completely identical, then we can say it could be possible that one wall is smooth or a little bit smoother than the other one, right? So force of friction could differ. Friction must be present on the two walls. Yes, now this is the correct one. Why? Because if there is no friction, his legs, suppose this wall does not have any friction, then his legs will not remain here. They will slide down, right? Also, consider if this wall doesn't have any friction, his hands will slide down like this. Okay. So remember, there must be some friction there. Okay. So it is not necessarily equal. If one wall is smooth, one is rough, then friction will be different. But yes, there must be some friction. The coefficient of friction must be same. Yes, obviously this is wrong. If the wall is rough smooth, then it is not necessary. It will be same, right? So now let's try this one. A 100 Newton force acts horizontally on a block of mass 10 kg placed on a horizontal rough table of coefficient of friction mu. So let's see what is happening. So horizontal table is there, rough table. Rough means friction is there, obviously. Coefficient of friction is also given. And force applied is how much? 100 Newton. G is given 10 meter per second. Normally remember G, this is actually, unit is not looking, right? It is something like that. Meter, yes, this to minus 2, right? Or you can say meter per second square, right? Like this. So this is just a little bit typing error, you can say. Okay. So it is meter per second square. We know we know the unit of G there, right? 100 Newton force is acting, mu is also given. So let's write external force. Whatever force they are acting, it is like you are pushing that block, right? Like you are pushing that cupboard, right? So F is 100 Newton. Friction force mu is given as 0.5. And the mass is how much? Mass is given as 10 kg, right? So there is no mu s or mu k given. So don't worry about that because we know both have the same formula. So whatever force of friction is there, whether it is a kinetic force of friction or the limiting force of friction, doesn't matter. The formula is same, mu n. And as long as you can see n is upward, mg is downward, we can also say that mu mg will be our force. Let's try to solve this. 0.5, then 10 into G, 10 kg block, na? Yes, 10 kg you can say. And G is also 10. So can I say this answer becomes 50 Newton? Right? So how much frictional force? Friction force is acting on this, 50 Newton. Doesn't matter whether it is kinetic or limiting. Actually, you know the answer whether it is limiting or kinetic when you can see the applied force. If the applied force is more than the friction, what I can say, this is my kinetic force of friction, right? So obviously this body will move, and they already have told us that body is going to move. But what is the acceleration? So how to calculate the acceleration? So how much force you are pushing the block with? 100 Newton. So, and who is opposing friction? How much is opposing? 50 Newton. Can I say F net is equal to F applied minus friction? So let's say this is 100. Friction is how much? 50 Newton. So how much is that? 50 Newton. So F net is the 50 Newton. And we know the relation between mass and acceleration. So first of all, always remember in this question, right? If the friction force is less than external force, first of all, calculate the F net. Once you got the F net, use the formula. Let me write it. Let's see. Let's write it here. So F net I got as 50 Newton. Say it is mass into acceleration because we know the formula of force is equal to mass into acceleration. But remember, do not directly say F is 100, so mass into acceleration is 100. No. First, we want to find out that who is opposing? Friction is opposing. How much? 50. So that 100 Newton, there will be one part, it will be to overcome that friction force. So we have to subtract that. Then we can write, right? Now acceleration will become 50 upon mass. Mass is also given 50 upon 10. So I can say 50 meter per second square. That will be my final answer. Okay. So this is how you can solve the question. Now let's move to the next one. The block of mass 1 kg lies on a horizontal surface in a truck. Right? Coefficient of static friction. Now static friction they are saying, right? Well, coefficient of static friction means what? Mu s. So first of all, let's write the given. So mass is 1 kg. Mu s is how much? 0.6. What is the force of friction on the block if the acceleration of the truck is 5 meter per second? 5 meter per second square. Okay, and they are asking us that what is the force of friction on the block? Okay, so you can consider now this is again the horizontal surface of the truck, and let's see, let's draw the truck. This is your truck, and block is kept on that truck, right? That truck is moving with acceleration 5 meter per second square. Okay, First of all, we have to calculate the frictional force, or we can say limiting frictional force. Let's say EFL is how much? Mu S N, or again we can say N is upward, mg is downward, so N will be mg. So mu S mg. So let's try to solve this one first. So this is 0.6, mass is 1, and this is 10. So how much is the force? 60 Newton. So what is the meaning of that limiting force of friction? That block will need the 60 Newton force to move, right? Okay. So this is the maximum limiting force of friction. What they have asked, force of friction. So if you apply only, let's say 10 Newton friction, our answer should be 10, right? Not 60. 60 is the maximum value. Okay. So who is applying the force? Is there anybody applying the force? No. But still there is one force applied on that block, which is actually called as, remember, pseudo force. So when the truck is moving, remember, pseudo force, which we can show it by the two arrows like this, will act like this on the block. And let's call this as pseudo force now, or our external applied force. So let's calculate the applied force. Applied force is equal to, I told you that it is also called as pseudo force. Why? Because the truck is moving actually, right? If the truck is moving, there is nobody is applying the force on the block. You can visualize this like when the, let's say, bus is moving, right? If the driver applies the brake, what happens? You fall into the front seat, right? Nobody is pushing you there. Same thing is here. If this truck is accelerating, nobody is moving that block, but still there is force applied, which is actually called as pseudo force. Okay, so this applied force we can say is ma. Mass is how much? 1 kg. Acceleration is how much? 5. So 5 Newton. So what is the applied force? 5 Newton. What is the maximum force to move the block? 60. Will the block move? Obviously not, because force is very less. So what is the force of friction? In this case, obviously force of friction will be equal to applied force. So it is not 60 Newton. Remember this very carefully. It is equal to applied force or equal to 5 Newton, you can say. Okay. So this is the force of friction and how you can solve. Very nice examples are very good, but your concepts need to be very nice, very good there. Then only you can solve such type of questions. So normally most of the students do this mistake. They they calculate the force using the formula and say yes, 60 Newton is the answer. But no, as the 60 Newton is the highest value of force of friction. It depends on the applied force. If applied Newton is only 5 Newton, why that will be a 60 Newton? Why friction will apply the 60 Newton? Right? So frictional force will apply only 5 Newton. Okay. So this is the answer. So in today's session, we have completed the whole friction part of this chapter, law of motion. Right. So hopefully you enjoyed this, and now you know that to slide the cupboard, if you have the wheel on the cupboard, below the cupboard, obviously it will be nice. Wheel, obviously cupboard does not have the wheel, but washing machine you can say. And you also know who is opposing you, who is stopping the motion of the cupboard, right? Good. Sure. So try to solve as many numericals as you can, and if you do have any queries, please post them in the forum, so I will answer them. Okay. Anyway, we'll stop here. Thank you very much. Have a nice day.